Welcome to Pomodoro Joe for Wednesday, July 19th, 2023. Today we're looking at LeetCode problem 435, non-overlapping intervals. This is a medium problem. So, given an array of intervals, where intervals index I is equal to start and end, return the minimum number of intervals you need to remove to make the rest of the intervals non-overlapping. All right, now the question is, do they count intervals that start and end on the same time as overlapping? Let's see here. So they've got 1, 2, 2, 3, 3, 4, and 1, 3. Output is 1 because we have to remove 1, 3, and the rest are non-overlapping. Okay, so that means 1, 2, and 2, 3 are not overlapping. So they can start and end on the same day or same number. All right, so let's put 25 minutes on the Pomodoro timer and we will get started. So it looks like our ranges can be quite diverse. So how do we approach this one? Well, anytime I run into something having to do with intervals, I ask myself, will sorting the intervals help? And in this case, I think it will. We want to sort the intervals so we can check to see if they overlap. So one option we could do, we don't have to sort them. We could just go through and check every single interval against every other interval, see if there's an overlap, and then remove one or the other of those intervals. However, if we do that, that means we're going to be comparing a lot of intervals that are nowhere near each other. So we'd be comparing things like 1, 2 to 3, 4 when they're not even close to each other. So if we sort the intervals first, then we don't worry about comparing things that are far away. We can actually narrow how many things we have to compare. So that's one good reason to sort. So let's start by sorting. Well, actually, let's start with a result and set it to 0. And we'll return the result at the end. All right, now let's sort the intervals. All right, so now we've sorted the intervals. How do we go about comparing them? Well, we can compare only adjacent intervals, but we still might have some that are slightly adjacent or a little bit further apart that are overlapping. So we might have to go through, check adjacent intervals. If there's no overlap, then we can move on. If there is an overlap, we might have multiple overlaps that we have to check. So how do we know there's no overlap first? Well, we're sorting by start and then end. So if our end, if we have, let's say, interval A and interval B. Now, if interval's A, if its end, so we'll have some start A and end A. All right, so if intervals A end is less than or equal to start B's start, then there's no overlap. A ends and B starts. There's no overlap. So because we've sorted these, we can check every interval against the next interval in the list, and if that interval's start comes after our current interval's end, then there's no overlap. So that's one key insight here. Now what's the next insight? So if interval A's end is after B's start, so there is some overlap. B starts before A ends, there's some overlap. Which one do we get rid of? We have to remove one of them. Do we remove A or do we remove B? I didn't do a great job of explaining this here, so I'm going to re-record a little bit of voiceover to see if I can explain this better. So at this point we have two ranges, and one of them will conflict with the other, or they conflict with each other. We need to choose one to remove. Which one do we want to remove? Well, let's remove the one that has the widest span, the one that's more likely to have conflict or overlap with other ranges. So we'll remove the one that has the largest end value, and we'll keep the one with the smallest end value because it's less likely to have conflict or overlap. So we'll just choose whichever one has the longest end time, and we'll remove that one, and we'll keep the one with the shorter or closer end time. All right, so let's go through this. So for every interval in our sorted intervals, so we'll check this interval's start against the previous interval's end. So its start will be at index 0, If this is greater than or equal to some previous interval's end, well, we don't have the previous interval's end, so let's do this. We'll just call it the previous end. So if this interval start happens after the previous interval ends, then we're good, and we'll just continue. Otherwise, we will have to remove an interval. So we'll add one to our result. And now we do need to keep track of this previous interval end. So let's have this out here. We'll just have some previous end. Now we don't actually have to keep track of the whole interval. We just have to know what was the last end time of any interval that we're tracking. So the previous end here will be our sorted intervals. Zero, 1. So this will be the end time of our first interval. All right, so we'll update our result, and then we do want to update our previous end here. So the previous end, now as we talked about, we want to choose the one that has the smallest overlap. So we'll choose the minimum of our current previous end, or this interval's end. All right, so we'll go through all of our intervals. We'll check each interval against the minimum previous end time of all of our previous intervals. If that start time happens after all the previous intervals end times, then there's no overlap and we can move on. Oh, but we do need to set our previous end here. So this previous end will now become this interval's end. All right. If there is an overlap, we have to update our result, and then we'll just choose the best end we can, which is the minimum of our current previous end or this interval's end. All right, let's try this. Oh wait, I got these mixed up here. The sorted intervals 0, 1. Previous end is just this interval's end and this interval's end. All right, that's more like it. All right, let's give this a try. And it totally doesn't work. Okay, what did I do wrong? That's the problem. So this is comparing our first interval to itself, which means we actually need to go from 1 to the end. All right, let's submit this, see how we do. And we pass, and we do not great, we do okay. We beat 46% for runtime and 78% for memory. So not bad, but not great. Let's jump back here and try to patch this up just a little bit. All right. Let's just make our own min here. All right, let's do this. All right, that gets us to a 51% for runtime and a 78% for memory. So not bad. Let's jump back, see what else we can do. That actually didn't do much better. That did worse. What? All right, I'm sticking with this one. All right, well, that's it for me. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and